This video will go over molecular geometry, known as the VSEPR model, valence shell electron pair repulsion. I'm not going to ask you to memorize that. Just know that when on the app, when it asks for you to have the VSEPR drawing, you are doing VSEPR. Okay, so we're doing molecular geometry, which basically is what do the molecules look like when they bond together. And we're going to focus on covalent compounds. Let me just show you on the ionic compounds. They kind of look like this. This is a salt crystal here. So they form crystal solids, and they get into kind of pretty much routine crystal geometry, so we're not going to focus on the ionic. And I do want to point here, do you see how the chloride is so much bigger than the sodium because it's a negative charge and that sodium is a positive charge? That's a salt crystal there. So what we're going to be focusing on is the covalent compounds because they're going to do some pretty random shapes on it. So this is your note page, so you can have that out. Everything that I'm going to be saying is going to be going over that note page, but I'm not going to read that to you. So we're just going to scoot on down past all these notes and we're going to get to the examples. And so that's what we're going to do, is we're going to work these examples for you. So let's look. Before we begin this, we're going to start with this carbon tetrabromide. We're going to see, we're going to do something called the Lewis dot structure. Now we did a Lewis dot diagram of an element, but now we're going to do it of a compound. And Lewis dot structure is going to be kind of like the rough draft. So this video is just going to go over the Lewis dot structure of the compound, and we're going to get that rough draft. And then the next videos will go over the correct geometric shapes, etc., to make the video not so long. So if we pull up the periodic table, we're going to remind ourselves of a few numbers. So we did valence electrons. We did 1, we did 2, and these were mostly 2. Now, we did have some 1s in here with our exceptions here and our exceptions there. And then it went 3, 4, 5, 6, 7. Helium belongs over there, so it was neon down 8. We're really not going to need to worry about these, even those exceptions, because we're doing covalent, and covalent are sharing their valence electrons, so we're going to be hanging on the nonmetal side. Remember, covalent, 2 or more nonmetals. I do want to remind you, these are the valence electron numbers. What happens with these are the oxidation numbers, these charges. And the reason I want to make a point on this, many times students will use these red numbers and you'll get wrong answers. So the red oxidation numbers, those are the charges for ionic compounds to write. So we are doing covalent compounds and we're trying to figure out how many valence electrons that they're sharing. So we're going to be using blue numbers. So be careful with that because it will mess you up. So ionic, when we're swap dropping, red charges, and the blue numbers for the valence electron. So I'm not going to be coming back and forth to this, so just know that we're going to use that. And so we're going to look at carbon tetrabromide, and the first thing we're going to do is just add up the valence electrons. So carbon has a valence electron of 4. I'm just putting a little 4 above it. And then we're going to add, because we're getting a total of valence electrons, we're going to add bromine to that. And so bromine is 7. But because there are 4 bromines, we're going to have to multiply that by 4. And you do have to do your order of operation. So you do have to do this one first. And so that's 28 plus that. So I have a 32 total valence electrons. So there's that. We're going to go do that for each one. We're going to add up the valence electrons. And so this is 4. I'm going to add oxygen is 6, but I'm going to multiply that by 3. Now see this -2 charge? This is carbonate, which is a polyatomic ion, which actually covalently bonds. But the reason it got charged is this is an anion. It has gained 2 electrons. So whatever this charge is, to your total, you're going to do opposite. So I'm going to add 2 to my total. So I've got 18, I've got plus 2 plus 4. That is a total of 24. On this one, we've got 5 for nitrogen, and then we've got 1 for hydrogen, but there are 3 of them, and so we've got a total of 8. So let's look at our next one. That was again the same one, but we've got oxygen, and there are 3 of them, so we have a total of 18. And again, all I'm doing is adding up, and so phosphorus is going to be 5. We've got 6, and we've got 7 times 3. So you've got 21 plus 11, so you've got 32. You can use a calculator if you need to. Bromine is 7. Fluorine is 7, and I am going to multiply that by 4. This is a negative one. I'm going to do opposite this charge. If it had been a cation, I would be subtracting, but it's an anion, going to add. So you get 28 plus 8, so I've got 36 electrons. And this is hydrogen, and it is 1 times 2, because there's 2 of them, plus 6, you get a total of 8. So that's our valence electrons, and that is our first step in doing our molecular geometry. So let's go back to the beginning of our page, and now we're going to start doing the Lewis dot diagram. The first thing we got to decide on is an element that's going to be in the center, and the element that's going to be in the center is going to be the least electronegative. So the least electronegative, remember electronegativity is up and to the right, and we want the least electronegative. I will tell you it's going to always be this first one. It's going to be our least electronegative, because that's how we write compounds. We write them in order of least electronegative to the most. I will tell you there's an exception as far as putting in the middle. If this one had been hydrogen, hydrogen is never in the middle of a compound. It's too small of an element, so it can't bond with more than one thing. So it's always what we call a terminal atom. So I'm going to put carbon in the middle, and then I'm going to surround it by the 4 bromines. It doesn't matter where you put them. Just randomly scatter them about. So I've just got them surrounded. And so what we're going to do is we're going to give the outside elements 8 electrons, and the way we do that is we're going to give them, and we don't care about this 7 anymore. What we're focusing in on is this 32. So we're going to give them 6 of their own, and then they're going to have to share 2. And so if you would like to draw one here, and connect it, that is absolutely fine. Or you can just draw a single line, which is probably going to be the better thing to do. This is called a sigma bond. So when I draw this, that means that 2 electrons are being shared. So when you draw a line, it is called a single bond, which is known as a sigma bond, which is the initial bond between 2 atoms. And technically it is the sharing of 2. We just draw a line, so we don't put that. So that is going to mean 2 electrons are being shared. So when we draw that line, you're going to know that it's 2 electrons. So that is 2, 4, 6, 8. So we're going to go 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So if I count this up, I've given out 32 electrons, 8 here, and so I had 32, I subtract 32, and so there are no extra electrons. What that means is there's not going to be any clouds on this particular element. We'll talk about that as we progress along. Alright, so once you determine that there are not going to be any clouds, and again we'll talk about that, so there's not going to be any clouds, that means extra electrons on the center element. We need to make sure that the center element has 8 electrons itself, and each line means 2, so 2, 4, 6, 8. So this one is not going to need a double bond. Alright, as we move to our second example, this is carbonate. Carbon in the middle, we're going to give it 3 oxygens, wherever you want to put it. Again, this is your rough draft. And so you're going to give 2, 4, 6, and there's 8. 2, 4, 6, and 8. 2, 4, 6, and 8. I give an 8 out. 8, 8, 8 is 24. There are no clouds. There's no extra electrons. But we have a problem with this one. The carbon needs to have 8. And right now this carbon only has 2, 4, 6. But I can't give it any more electrons. So what you do is you're going to pick one of the oxygens. I'll pick this one. And I'm going to erase 2 of these electrons. And I'm going to draw a double bond. What this double bond now is a pi bond. So when you do a double bond, it's a pi bond. I made a different color for we could see. And so we can see here that we now have created a pi bond for this. And so if I count, I still have 24 electrons, but this one is sharing 4. So 2, 4, 6, 8. Now this center atom is happy.